Hello children, today I am going to tell important points for ammonia chapter. So till page 170 I have already told you. So from page 171 only the reactions and conditions from this page are important. So the reactions which are important is burning of ammonia and oxygen. So here you can see when ammonia is burned in air, it combines with oxygen and nitrogen is formed because it undergoes oxidation, and here nitrogen and hydrogen separates, so you get nitrogen, and hydrogen which is separated, it combines with oxygen to form water, and it burns. When it is burning, it burns with greenish yellow flame. Then the second reaction, it is catalytic oxidation of ammonia. It is also known as Ostwald's process because this particular process, in that nitric oxide is formed, which is the initial process for the production of nitric acid. So here what happens is ammonia is burned with oxygen, but in the presence of catalyst, that is platinum, and the temperature is important, that is 800 degrees Celsius. And here the compound which is formed is nitric oxide, water, and heat. It is exothermic reaction. This you have to remember. Second thing you have to remember, that the flask in which gas is collected shows reddish brown gas. The reason is nitric oxide undergoes further oxidation and forms nitrogen dioxide. So it is a reddish brown gas in the flask, and the catalyst used is platinum. After the reaction is stopped for some time, you can see that the platinum glows for some while. The reason is, it is, as the reaction is exothermic reaction, the heat which is there, due to that platinum continues to glow. Okay, next is on page 172. You have to just remember that ammonia gas is a basic gas, or it is basic in nature. After that, below on the same page, you will see that three reactions are given. Those three reactions are only important. That is, when ammonium hydroxide reacts with acid, what is formed? So whenever ammonium hydroxide, as it is basic in nature, and it is reacting with acid, neutralization takes place. So corresponding salt and water is formed. Now ammonium hydroxide, when it reacts with hydrochloric acid, you will see ammonium chloride and water is formed. When ammonium hydroxide and nitric acid reacts, you get ammonium nitrate and water. When ammonium hydroxide and sulfuric acid reacts, you get ammonium sulfate and water. After that, page 173, these all reactions are important. Now here you can see the reaction of ammonium hydroxide with different salts are given, which is also there in analytical chemistry. So this particular reactions you have to learn, and you have to remember the color of PPT. So here very important thing is, when this, you have to remember that this particular reaction is double decomposition reaction, because the exchange of anions is taking place, and the color of PPT depends upon the valency. For example, if you are taking iron, there are two iron, that is iron with valency 2. When it reacts with ammonium hydroxide, you get dirty green PPT. So iron, like here it is ferrous sulfate, so it is having valency 2. So here the PPT which is formed is dirty green PPT. When iron chloride, which is having the valency 3, that reacts with ammonium hydroxide, again exchange of anions taking place. Here ammonium chloride will be formed, and ferric hydroxide, that ferric hydroxide is reddish brown PPT. After that, lead nitrate, when it reacts with ammonium hydroxide, you get exchange of anions, so ammonium nitrate you get, and corresponding lead hydroxide is formed. The color of lead hydroxide is chalky white PPT. Now after that, you have to remember that what happens when excess of ammonium hydroxide is added to these three compounds. So in these three compounds, you have to remember that it remains in insoluble form. That means the color of PPT, if it is dirty green PPT, you will see that dirty green PPT if excess ammonium hydroxide is added, because it remains in insoluble form only. So for all these three, it remains in soluble form, that is iron 2 hydroxide, iron 3 hydroxide and lead 2 hydroxide. So for these three, remember that they remain in insoluble form in excess of ammonium hydroxide. But these two compounds, that is zinc sulfate and copper sulfate. Now when zinc sulfate is reacted with the ammonium hydroxide, the compound which is formed is ammonium sulfate, again exchange of anions, and zinc hydroxide. Now the color of zinc hydroxide is gelatinous white. Remember it like that. And what happens in excess addition of ammonium hydroxide is this particular PPT now becomes invisible. That means you get it in a solution form. The reason is the compound which is formed now after addition of excess of ammonium hydroxide is tetraamine zinc sulfate. You don't have to learn the molecular formula of the compound, but name of the compound just remember. But this reaction is important, and it is important for you to remember that in excess it is in a solution form, so it becomes soluble. The PPT was insoluble and it becomes soluble. Then about copper sulfate. When copper sulfate reacts with ammonium hydroxide, again exchange of anions. So ammonium sulfate is formed and copper hydroxide which you get is pale blue PPT. Now this particular pale blue PPT also, when you add excess of ammonium hydroxide, this is in a soluble form. So you get a solution of copper hydroxide. But then when it is in a solution form, the compound changes. It is now tetraamine copper sulfate. Okay, so these reactions plus whether it is in a soluble form or an excess addition of ammonium hydroxide or insoluble form, that you have to remember. So remember the color of PPT also. Now next we go to the next stage, that is on page 174. This particular property of ammonia is very important, that it is a strong reducing agent. Under that property you have to learn these three reactions. As it is told that ammonia is a strong reducing agent. So what happens when it reacts with copper oxide? Now you have to remember, under metal oxide there are two metal oxides given, but you don't have to learn about lead oxide. You have to only learn about copper oxide. So now as it is a reducing agent, it will reduce this copper oxide. Reduction means removal of oxygen. That means it will remove this oxygen and what will be left is only copper. Now as this is a reducing agent, it will undergo oxidation. Oxidation means removal of hydrogen. So from ammonia, hydrogen will be separated and nitrogen will be left. So you will see one compound is nitrogen. This particular hydrogen which is separated from ammonia now will combine with this oxygen and form water. This is how you have to remember the compounds which are formed, the products which are formed is copper, nitrogen and water. After that, what happens when ammonia reacts with chlorine? But if ammonia is in excess, what will be the product? And if chlorine is in excess, what will be the product? This you should know with the equation. So when ammonia is in excess, as ammonia is a reducing agent, it will reduce this chlorine. Reduction means addition of hydrogen also. So it will add hydrogen over here. So what will be the compound formed? HCl. Now this particular HCl, as ammonia is in excess, will react with ammonia. And as you know that when ammonia reacts with HCl, you get ammonium chloride as one of the compound. So ammonium chloride will be formed. Now in the first reaction, as I told you, ammonia is a reducing agent. It will undergo oxidation, means from that hydrogen will be removed, which will combine with chlorine. So this hydrogen, when it is removed, only nitrogen is left. So the other compound which is formed is nitrogen. So remember, when ammonia is in excess, the compound which is formed, the product which is formed is ammonium chloride and nitrogen. After that, the next reaction, which is again very important, that when chlorine is in excess, what will be the product form? So as I told you, this is a reducing agent and chlorine is in excess. So hydrogen from here will be removed and it will combine with chlorine, forming HCl, and the nitrogen which is now left out here will also combine with chlorine because chlorine is in excess, and you will get this particular compound, that is nitrogen trichloride, which is yellow explosive liquid. You have to remember it's a yellow explosive liquid. So these three reactions, equations, practice it. It's very, very important. After that, page 175, you have to remember What will be the color change with litmus when ammonia is tested with litmus paper? So it will show red turning blue. Methyl orange, if it is tested, orange will turn yellow. Phenolphthalein, if it is tested, colorless to pink, this change will be seen. After that, same page 175, you have to remember ammonia, when it reacts with HCl, you get ammonium chloride. This is one of the very important reaction, and also confirmatory test for ammonia, identification test. That is when you dip the glass rod in HCl and take it near the mouth of the jar containing ammonia, you see white dense fumes of ammonium chloride. That is the identification or the confirmatory test of ammonia. So this particular reaction equation is important. Then on page 176, uses are important, but learn it from the notes which I will be sending. Okay, thank you.